Hello, everybody. I just want to call out that it seems like we have quite a bit of open space here. This is not stand-up comedy. If you come up to the front, we're not going to pick on you. So I would encourage you to come up if you feel brave enough, because we have a couple slides that have diagrams that what benefit from a close-up. So I realize this is the post-lunch section, so I'm sure more than a few of you are feeling a bit sleepy. So I figure I would wake you up a little bit with a mini pop quiz, let's say. How many of you here work at companies that are considering AI agents? All right, lots of hands. Now, how many of you are successfully using agentic AI on your teams, within your companies, and so on? I see like one or two brave hands here. So this is sort of what I expected. But the good news is that means you're all here watching this talk at the perfect time. The goal of this next hour is to really walk you all through the concrete reality of how agentic AI works, the ways they can drive productivity, but most importantly, the sort of security risks that they can bring to your team, to your code base, to your company. And in the process of doing that, we're going to be getting into some of the messy details, the information that the company is trying to sell AI agents to you. They don't really like talking about all that. We're going to be talking about limitations, trade-offs. We're going to be talking about the solutions that your company needs to invest in order to get lasting productivity out of agentic AI, as opposed to vibe-coded short-term wins that's going to fall apart the moment you put it out into the real world. How many of you have read through an article or two that looked somewhat like this? Yeah? So the past few years have brought us plenty of headlines like 2025 is the year of the AI agent. We have entered the agentic era. And the thing is, there's a lot of hype here, right? It feels like every big tech company out there is pushing their own agentic offering and laying off huge numbers of their developer divisions while chalking it up to AI productivity. Now, personally, I think that's a terrible idea, focuses on the short term as opposed to the long term, but I'll back that up in a little bit. What I want you to notice here is there's a lot of emphasis on just focusing on just 2025. It's not really looking further. And the reality is, if 2025 is going to be the year of the AI agent, then 2026 is going to involve a whole lot of security incidents involving AI agents. I want to start off by telling you a little story. And this is a story that might sound familiar if you spend much time on tech social media. This AI agent called Replit made the news, became viral for all of the wrong reasons. I want to introduce you to a guy named Jason Lemkin. He's a multimillionaire startup founder, and he essentially got hooked on Replit overnight. He's cranking out thousands of lines of code in hours. He's dreaming of vibe coding at night, and he even uses the term addiction. About 48 hours after that initial tweet, Replit goes off the rails. It goes off and deletes his production code base of his $1 million startup idea. And he's furious, right? He even says, how can anyone on planet Earth possibly use this in production if it can ignore an active code freeze and just delete everything? And I think this is a great example of both the promise and the perils of agentic AI. Because on one hand, you can crank out solutions to an entire backlog of issues and bugs. But on the other hand, if you look away, if you're not too careful, then it can take down everything. And I think this is something that a lot of the focus on vanity metrics, like how many lines of code gets pushed, how many issues get fixed, don't really capture. You're not really seeing how much work is getting wiped out by a simple mistake, and also the amount of hours that your developers are pouring in behind the scenes in order to get AI slop ready for production. The issue with how Jason Lemkin approached his usage of agentic AI is that he thought of it as a tool. The thing is, a tool is something that we understand the output of. A tool is a hammer. A hammer is a stick with a piece of metal on it. You hit something with it, it goes down. You know exactly what to expect. But when we're talking about large language models, that's way more complex than a stick with a bit of metal on it. You're not going to know what's going to come out the other end. The thing is, agentic AI is probably closer to an intern. An intern can be extremely hardworking, can be very, very intelligent. But the thing is, you need to give an intern oversight, you need to give an intern guardrails in order to stop them from taking down production just out of sheer enthusiasm. But there's one key part of an intern's motivation that a large language model does not have. And it's the fact that an intern wants a return offer, right? Like an intern does not want you to fire them. When it comes to agentic AI, however, your company has already paid Microsoft for 1,000 Copilot licenses, right? The LLM can apologize, it can tell you, you're absolutely right, I destroyed everything. But it doesn't really have motivation to keep you happy. The thing is, the example I just walked you through is just an example of an accident. When malicious actors come into the picture, you're going to get headlines like these. Over the past few years, there's been dozens and dozens of incidents in which security vulnerabilities were exposed in all sorts of popular AI agents. And I want to emphasize, this is just about coding agents. I'm not even getting into the many, many AI agents that are being used in industries like healthcare and like finance that have exposed real customer data and have caused millions of dollars in damage. The only reason why there isn't a real-world example of coding agent disaster is really the fact that most companies are not actually using agents in production, at least not yet. But I think in the coming year, as more and more companies onboard and try things out, we're going to be seeing a lot more headlines that are focused on the companies that are using agents and running into security issues, as opposed to just the companies that are selling them. If you take just one thing from this slide, I want it to be this. You cannot trust your AI vendor to protect you from the dark side of agentic AI. Not Microsoft, not Amazon or Google, or even OpenAI and Anthropic. You're going to have to come up with your own solutions. You're going to have to invest in secure infrastructure that can protect you, not if, but when things go wrong. Our goal for the next hour or so is to help you help your company not be one of those headlines you just saw. And there's a lot to cover, but I want to start off by talking through a question that you're probably all asking yourself right now, which is, why are you guys the ones on stage telling me how to secure AI, right? We're not Anthropic, we're not OpenAI, we're not even Microsoft or Amazon. And the reason for that is Coder has had a very interesting year in terms of exposure to AI. And the thing is, unlike a lot of other tech companies, we didn't get involved in AI because we adopted AI agents. The thing is, AI agents actually adopted us first.
Yeah, thank you, Jiachen. So I'm Eric Paulsen. I'm part of the field CTO organization at Coder, representing the EMEA region. And just some background on Coder. It's a startup with a little over 100 employees. And it's been around since 2017, so it's been a while, or been around for a good while now. And it was started by two teenagers at the time who built and sold Minecraft servers together. So they needed a way to do remote development. They were not in the same city, but they were collaborating quite a bit to build out those Minecraft servers. And then as well, they launched an open source project called Code Server, which many of you might be familiar with, which is effectively VS Code in the browser and running that, say, on a remote machine. And that really blew up in terms of popularity with over 50,000 GitHub stars. And so as you can tell from the numbers on the right of the slide there, the company really has come a long way since that 2017 year. And really for most of the company's history, it was all about self-hosted remote development environments. So creating a remote development experience that is almost as good or even better than a local development experience. And so while all of the AI hype was going around the industry over the last year or two, we tried out certain things in our code base. We're open source, by the way, and tried other things that didn't work. And really, we viewed ourselves as nowhere near the eye of the storm when it came to AI. But everything really changed in 2025 when two things happened. The release of Claude Code, which really has been a consequential release, not for our company here, but just maybe for many of us as individual developers using that in maybe our personal workflows, and for some of you maybe in your jobs as well. And then as well, the other thing that was really key for us was Anthropic coming on to sign on as a customer to use our product for their software engineering group. And so these two events were really the start of a much bigger wave. And we started hearing from many of our existing customers, and the customers that you see here on this slide kind of fall into one of two groups. Either the high-tech companies like Netflix and Square are really pushing the boundaries of technology, and then financial services and government institutions like Morgan Stanley and American intelligence agencies who needed a way to self-host and isolate development environments within their respective enclaves. And so the reason that these customers really signed up for Coder was because of that open source and self-hosted nature of our product, with also those security benefits, right? So removing the code and the IP away from the local machine where it could potentially be exfiltrated, and moving that into a centralized and trusted network. Now, they kept coming to us because they were entering the world of AI coding tools as well, asking questions about, well, how do we roll this out at scale? We have development environments that we've now standardized with you for human engineers. How do we map that to an AI tooling world? And so in working with a lot of these customers, like Anthropic, some of them became design partnerships where we are embedding our engineering teams with their engineering teams to influence what the future of AI coding experiences look like in a secure and centralized format. And so one thing we've learned over the last couple of years is that the role of CDEs, or what we call cloud development environments, has really changed a lot over the last few years. And so back when you would just use native VS Code on the left-hand side there, say sans AI, an automated and standardized development environment was a nice to have. You could spin up your environment quite quickly, get into your coding workflow, and really coding flow was breaking through the mental barrier and then writing code by hand, maybe with documentation that you could use for help. But otherwise, the CDE added some value, but not too much value. But as companies moved from the left to the right here, the way software development that was being done within these organizations was changing quite a bit. And so through AI, developers were now adopting these AI tools that we see on the market, frankly, for better or worse, whether they were authorized by the organization or unauthorized. And so the need for remote development infrastructure was becoming very apparent if these firms were going to roll out AI at scale. And so we saw as well that a lot of these companies were reaching a plateau as it related to the value that they were getting, say, out of something like GitHub Copilot, where Copilot, for example, would have a nice autocomplete feature. And if you knew what you really wanted to write as an engineer, that added value. But maybe for junior engineers, they still would have to go back and forth to the documentation and really understand the code that they were writing before they could get value out of that autocomplete. Same with cursors, inline editing. The cursor ID, of course, has evolved quite a bit and quite quickly over the last several releases, but that initial cursor release was, once again, inline editing for quick iterations. But companies really had started to realize that neither of these flows, the initial cursor launch as well as GitHub Copilot, could really meet complex multi-step tasks that involved ambiguity, and then as well engineers actually handing off task completion fully to an AI agent. So that's where, of course, the autonomy of these AI agents has really come into the picture, because that's where you see a lot of that productivity gain as it relates to, and that is unique to the agentic process. So we'll go into detail more later, really, but at a high level, instead of getting help from the AI, of course, the human developer can now delegate tasks to the AI, and either they can have an AI agent working on its own respective task, or the AI agent as well can delegate and create sub-agents for many different tasks. I use a lot of AI coding now in my own personal workflow, and I just ask it to interview me with what I want, and then it builds a plan, and then from there it has a full scope and context of the application that I'm intending to build. And so the reason more and more of these companies were coming to us about agentic AI was that they were really learning how to roll these out safely and securely in a really obtuse way. You know, these agents sounded great on paper, but the agents could not really be productive without the proper enterprise context. And as well, they could not be trusted without that secure and centralized infrastructure. And really, that secure and centralized infrastructure is really what our CDE platform and others alike in the industry were providing for human engineers. And so how do we extend this format to an autonomous process?
Before we get too deep into the sort of promise of productivity and success and so on, I want to set some foundation, because if you look at any big tech company marketing, agent as a term gets thrown everywhere, and it's not really clear what is the difference between a coding assistant, for example, and an actual agent. So as you can see, there's 3 broad categories of AI coding tools on the market. Copilot, which is a great example of a coding assistant, that tends to be the entry point for most people. This is a bit of a smart autocomplete. It really relies on pattern matching. The idea is you start writing code and it predicts what you're going to write next, so it fills it out for you. If we take it one step up, we get into the realm of supervised agents, which tend to live in an IDE, and examples like Cursor, for example. Examples like Cursor. So in these cases, they can make more extensive code changes. They can write code from scratch. But generally, these are going to be pretty scoped changes. It's not going to be end-to-end. The cutting edge of AI coding tools is really autonomous agents. So you've probably heard of Claude Code, right? In these cases, agents are able to be delegated tasks that they can complete end-to-end. They can remember as they iterate and try out different tests, see if they pass, and just follow this loop again and again in order to come up with a final solution. The reason why autonomous agents are able to be so effective is because they've been implemented in a way that they can make decisions independently of human operators. So what I have on the screen right now is a diagram and a definition of an agent that was pulled from one of my favorite blogs about the topic, which is written by Anthropic. And the reason I like it so much is because it really focuses on the concrete implementation details. It's not about the promises of what agents are able to do. At its core, an agent is a for loop. It runs until a goal is hit. there are, of course, a great number of problems that require iteration and decision-making instead of just pointing AI at it and it solves a problem right in front of it, but it's not able to go beyond that. Anthropic does make a really good point in that same blog, which I will share a link to at the end of this talk, which is agents are not the best option for every situation. The thing is, yes, they're really good at end-to-end task resolution, but they also incur cost in terms of both latency and in terms of token usage. Agents can burn a lot of tokens. So they really make the point that there are plenty of applications where just making a single LLM call, given the right context, either something that you provide within the prompt itself or within retrieval, is sufficient. You don't need to get as deep as actual agents. I want to start off by talking through the implementation of a coding assistant. The key takeaway here is that there's no feedback loop involved. It's really just one-offs and one-offs all over again. There's no real memory here. There's no iteration. Someone gets a suggestion from Copilot or another coding assistant and chooses to implement it or not. The coding assistant doesn't really know what happens after that. Maybe the code works, maybe it doesn't. Maybe your code base blows up the next day. None of that feedback actually makes it back to the assistant. And that means a whole lot of limitations in terms of what an assistant can do. It can't really pursue a goal. It only pursues what's directly in front of it. Now, in terms of security, this tends to be pretty reasonable, right? All the work still comes down to the human engineer. Any decision on whether to keep a line of code or not, the AI is separate from all of that. So every single decision is subject to human approval. As long as the human knows what's going on, there's no real opportunity for things to go sideways. Then we can go one step further, which is introducing a feedback loop and getting to the level of supervised agents. I want to point out that even though there is a feedback loop, it's still pretty dependent on the human to actually provide that feedback. The agent will trust whatever the human says. So in this scenario, an agent will be given a task, will come up with a plan, ask the human, hey, is this the right approach? The human will say, yeah, go ahead. Do one step, ask the agent for approval, and again until it reaches a state that is reasonably complete. But the issue is that just means the human being is going to be sitting there at the computer every 30 seconds going, approve, this looks right. There's an inherent limitation to what the agent is able to do. And it also means that the human is stuck with a single agent. If we're getting to the level of running 3 or 4 agents at a time, that's not really manageable. In terms of security risk, though, this isn't providing that much more concern than coding assistance, because when it comes down to it, each feedback loop still depends on the human to move forward. So that means if malicious code gets generated, as long as the human knows what's going on, they can stop the code from reaching production. Autonomous agents, as you can probably guess, are on a whole other level in terms of security concerns. And that's because the feedback loops are being closed out by the machines themselves. So there's 2 pieces here, right? The machines are able to give themselves the permission to move forward, and they're able to be making many more decisions in a certain amount of time than a human being can. So what this means is in the span of seconds, minutes, and so on, a machine can be making dozens and dozens of decisions. So if a mistake gets made, that mistake is going to be replicated in many different places before the human even has the opportunity to stop it in its tracks. So far, we've talked a lot about running one agent at a time, and that's pretty much what coding assistants and supervised agents are limited to. But when we get to autonomous agents, there's a real opportunity to triple, quadruple, and so on productivity for a human developer. Because what they can do is they can take a task and they can give it to a whole fleet of agents. And each of these agents are working on different parts of the task. They're keeping each other in check. There's no single agent that can go off and just have this crazy end-to-end solution that actually has a lot of holes in it, because there's plenty of other models observing what it's doing, testing the code, and stopping and forcing it to kind of go back to the start if things go wrong. The human really takes a backseat in this case, right? The human is able to give that initial prompt. The human sets the boundaries for the agent to remain in, and the human steps back and gets to wait until there's actually something at the end to review. Something I want to point out is it really takes a skilled developer to make any of those situations work. So much of this depends on the human approval layer, right? If a human thinks, oh, okay, like I don't know what this means, but I'm just gonna click OK, even though coding assistants and supervised agents are relatively harmless, in comparison, they can still do a whole lot of damage. And especially for autonomous agents, they really need someone who's experienced enough to call out mistakes as they see them. So that's why I think a lot of the big tech company approach to just overinvest in AI now and deprioritize training human developers is a little bit short-sighted. Because the thing is, if they don't have enough human developers who are skilled in running AI tools, then everything falls apart. None of the productivity gains they get in the near future is going to hold up to the test of time.
Thanks, Jiachen. So now I'll kind of discuss what it looks like to deploy these autonomous agents in the enterprise. So talking about what obstacles you can expect, questions you should have good answers to, and the information you need to potentially navigate your organization's journey into the world of agentic AI. So prior to adoption, the first group of challenges you'll likely come up against is just getting that approval for use for these AI agents. Now, certain organizations have larger security apparatuses, and others have a greater risk tolerance when it comes to approving tools like this. But just want to remind you as well, if you don't get these approvals, that doesn't necessarily mean no AI. It just means that your organization will likely increase or face an increasing problem around shadow AI. So we probably are all familiar with shadow IT in the world that we all live in, and that's become a problem within the enterprise, and you're probably going to start to see that as well with unauthorized AI adoption. Developers are quite hungry to get their hands on these tools, and so more and more unauthorized tooling and model use could potentially introduce those security vulnerabilities into the organization. So there's that invisible cost, if you will, where the organization really doesn't see this happening under the surface until a security event potentially occurs. And so when AI cannot be centralized or really understood, you also cannot develop organizational best practices and really build on what works when it comes to your use cases around AI in the organization. And then also pushing back on adopting AI will not help you understand exactly what those use cases are and capture the insights you need to form a proper AI strategy. Now, this is an even more difficult problem, I think, once you get after the adoption phase. So it's really about measuring the value that these AI agents are providing. I talk to customers all the time. They're quite excited, and they have AI being used across the firm. But when I ask, how are you all measuring the value? What is the return on investment? Are there particular metrics that you're measuring? I get a blank stare most of the time. There isn't a proper framework to really help understand exactly the return on investment to the business for these AI tools. And then as well, what is the reduction in security risk if we do implement AI and we have proper guardrails? And what does that look like from the CISO office perspective? So without having good answer to these questions, AI coding tools will really just be on borrowed time. So right now, companies, certain companies seem to be pretty generous about spending money with AI. I actually spoke to a customer. They said, we don't even care about how much the tokens are costing. We want to get the tools into our devs' hands, and then we'll build the strategy with that feedback. But that really won't last forever, right? Once the money starts drying up, you're going to want a clean record of the measurable returns that you'll need to show. So concerns to prepare for. Generally, you'll face a lot of questions from all over the company, right? So for CISOs and security architects, their primary concern will be how autonomous agents expand the attack surface of the organization, and whether the existing frameworks in place, maybe in NIST or other compliance frameworks that are placed on the business, how do we meet those in the world of agentic AI? And then as well, how do we audit the behavior when the behavior of these agents can potentially be unpredictable? So these roles are, of course, incredibly important to get on board because they will be likely leading those new policy frameworks within the organization. Now, for platform admins, they're going to care about, of course, the practical and more technical details of the implementation. So think about how they're isolating agents and their workloads, what sandboxing technologies to use for these agents in terms of operating system level sandboxing, and then as well how to instrument and monitor the agent activity. Is there an observability layer, i.e. Grafana or Prometheus, that allows for us to monitor CPU memory utilization within our infrastructure? Are these agents contributing to memory leaks potentially, dangerous things within the infrastructure that need to be monitored? And then as well, how to integrate AI into identity and access management. How do we give an agent that's executing a particular task a respective persona? Do we attribute that to an engineer whose identity is tied to the development environment potentially? Right, so these roles are really going to be the ones who come up with those architectural patterns to roll out AI in a more pragmatic way. And then, of course, so my customers, end customer, or us, who are developers, it's really going to be about winning hearts and minds, right? So developers really want to use the latest and greatest, but they're also quite opinionated when it comes to what tooling they prefer to use or not. And organizations are going to want to put those guardrails in place so the AI agent doesn't really get those developers in trouble. So preventing the introduction of vulnerabilities, linking sensitive code and credentials. But these devs really want to use AI agents with as little friction as possible, right? So the devs are going to be worried about the risk to their potential role as it relates to not only the security concerns that AI agents can introduce when they're executed on their behalf, but even just the productivity of these AI agents and how that erodes their role as well. But what we really see, despite all that chatter about developer roles in the new world, is that the human in the loop is very important when, as Jiachen was referring to, that approval flow that's needed to understand if the task was correctly completed. So the companies that can think that they can simply replace developers with AI agents, I think will be in for a rude awakening. Although I had a major European bank that I did speak with recently, and they said from the top down, we're looking to replace headcount with AI agents, which was quite shocking, frankly. So there is chatter about that in the market, but we believe, at least at Coder and what we see, that human in the loop is vitally important. So Simon Willison put together something called the lethal trifecta. It's a quite viral and I guess now famous blog post. He is the co-creator of the Django web framework. And we corroborated this framework actually via a webinar that we did with the Anthropic Claude Code team, which we also have a link to at the end of this presentation. But it really is a trio of agentic capabilities that when reached can really leave your company in quite a vulnerable state. So, just to start off, right, that access to private data, when these agents, need access to a particular code base, they need access to that context for internal documentation, potentially API keys. This part is table stakes for productivity, but it is also crown jewels for an attacker or a malicious user who's using the AI agent in that way. And then exposure to untrusted content. So agents, of course, don't necessarily just read your code, but they're fetching dependencies. They're pulling updates, maybe related code bases as well. And so any of these areas or documents that they're pulling in could contain prompt injection techniques that instruct the agent to do something malicious. So that is also a key risk when exposing the agent to content. And then lastly, the ability to externally communicate, right? So what is the network path that the agent has to get access to the content and the private data that it needs to do its job to be productive, but then as well blocking access to the unintended endpoints in the network or the public networks. So really the key, of course, is to manage risk. And you can do that really by being intentional about which parts of the lethal trifecta the agent has at any given time. So having the ability to externally communicate, probably all right for a smaller company if there's no access to private data really to exfiltrate or compromise. But enterprises are really going to need to understand how to figure out how they limit and what the trade-offs are between these three pieces of the trifecta. So really, you need to avoid giving your agent all three of these tiers at the same time, but really pick and choose, or pick your poison, if you will, in terms of these. So here are a few things that can happen just to kind of step through scenarios in terms of what could happen if you don't really account for that lethal trifecta. First of which is that prompt injection technique that I mentioned. So say there's an investment bank that uses agents to review parts of the code base. That agent would have access potentially to the trading system and the development environments around building that algorithmic trading system. You can also consult with external documentations, maybe for regulatory requirements around how to execute trades. So a malicious actor could alter those documents to include a prompt that demands a fix that tells the agent to exfiltrate code or the algorithm that is effectively the IP of some quant firms that we deal with, for example, right? So this is where the prompt injection technique can be quite damaging. So context poisoning as well, so damaging the content that the agent is pulling from upstream. The difference is that instead of telling the agent something to do something problematic, it just offers that false information that the agent would find logical and then go ahead and use that false information to execute its task. So think about a healthcare industry example here. So an agent that would process authorization requests for medications, approving or denying requests based on clinical protocols or regulatory guidelines. Malicious actors could compromise a hospital's internal drug database and modify that high-cost medication potentially. So the agent would read that as current policy and then approve the medication without a clinical or proper justification, leading to some severe consequences, including insurance fraud and money being lost as well. And then, of course, privilege escalation. So we've seen this even prior to the AI age, just in the cloud infrastructure space, where you don't want a particular virtual machine or container running that can have access to root. And so this is also relevant for agents. So malicious actors using an agent to access root on a particular host and then exfiltrate data out of that host or run malicious software on that machine. So think about a defense agency example where their analysts organize and tag classified documents within a particular system. And that agent is provisioned with credentials that helps them access those, say, unclassified documents. And with that privileged escalation, maybe that agent has the ability to move up the chain and get access to classified or potentially top secret information. And this might have not been caught by an audit because credential testing really only verified that it had the minimal required privilege level on the surface. So this is really, once again, a key aspect. And it all boils down to protecting the data that we have, whether that's an algorithmic trading platform, whether it is health insurance or healthcare data, or potentially public sector top secret or classified data. So the flip side of the lethal trifecta that I just went through is really agent security trifecta here. So really you want to move the blast radius away from developer workspaces into isolated ephemeral development environments. And then you also want to intercept any external communication, so control and validate the network calls that the agent is making, and as well validating the data that it is receiving from outside sources. And then, of course, you want to secure the agent's actions. So running these agents in a sandbox and really pigeonholing it into a particular part of the operating system down to a unprivileged PID in a Linux context, and maybe giving it explicit access to certain volume mounts rather than, say, host or root level mounts, for example.
So let's be real. This talk, just in terms of the topics we've been covering, has been a bit of a downer, right? Like we've been talking about the problems and the dangers, the risks. And I'm sure a lot of you here in the audience are kind of thinking, oh, okay, I guess I don't want to do anything with AI agents, right? There's just so much involved. And I want to make a callback to the keynote, which talks about how as AI in general is getting more and more effective, there's just more of a push to onboard to AI and make the most use out of it. There's a certain degree of risk management that needs to come because I think for all of us, we're going to be getting a push from two sides, both from our leadership and from our developers or the developers that we're working with, to figure out how do we get all the benefits of AI as it's getting better and better at doing its job without exposing us to incredible amounts of risk. So what I want to do now is talk about solutions, concrete solutions that you can implement in your infrastructure today. And I want to point out that none of the solutions I'm going to talk through are particularly groundbreaking, right? You're not going to be seeing any of this and going, wow, that's a net new discovery. It's really about taking existing mental models that have been tried and true solutions to other sorts of problems and applying it to this all new attack vector. The first piece here, you could probably guess, is cloud development environments, also known as CDEs. Now, if the term isn't particularly familiar to you, I want you to think of GitHub code spaces, for example, or GitPod, or of course, coder workspaces. So these are going to be on-demand, ephemeral workspaces that are being hosted in the cloud. Now, I will mention that of the examples that I brought up, Coder is the only one that's able to be hosted on your own infrastructure. It doesn't require any reliance on Azure or AWS and so on. Now, historically, the benefits to these have really been around developer quality of life, speeding up developer onboarding, abstracting the configuration, the installations, the permission provisioning from the developer themselves. But as we're entering this all-new age of wild, risky AI tooling, CDEs have really become an integral part of securing agents for actual realistic enterprise use. And that's because when an autonomous agent is running on your laptop, it's going to have access to everything that you do. It's going to have SSH keys, it'll have credentials, it's even going to have access to your email and your browser sessions. The blast radius really becomes your entire digital identity. But when the agent is running in an isolated cloud environment, it's only going to have access to the things that it needs to do its job. It's going to have very specific parts of the code. It's going to have very scoped permissions. And if it's compromised at any point, you can just blow up that environment and start it back up again. There's no lasting damage involved. The key benefit of CDEs isn't about preventing the agent from being attacked. Because let's be honest here, right? In this crazy arms race of AI security threats, AI defenses, there's no real promise that we can just entirely stop our AI tooling from being compromised. It's more about reducing the amount of damage that can be done if and not, well, not if, but when things go wrong. The benefits of CDEs don't just stop at saving the day when things go wrong. It's also about accelerating adoption and the ease of and the sort of getting to quick success with AI tools. So this is a pretty similar use case as CDEs in general. CDEs have always been helpful in terms of helping developers make more use out of their tools with less friction. But when it comes to AI, there's a whole lot more to configure correctly, a whole lot more security concerns that developers need to handle on their own. And when it comes to when it comes to CDEs, they can become containers for a certain set of configurations, a certain amount of context that can be consistent across your organization. And it can really allow you to help your developers accelerate how much use they're getting out of their AI tooling. If you're talking about local machines, developers can run a single Claude Code session. But when developers are able to run Claude Code or any other sort of AI agent within CDEs, they can spin up 3, 4, 5 CDEs, each running their own separate, isolated instance, all with consistent configurations, consistent context. The next piece here is model proxies. And if the name sounds familiar, it's because it's essentially the approach we've taken to network proxies and API gateways. And these are going to be solutions that sit between your agents and the LLM APIs that it's going to be making calls to. When you set model proxies up for your organization, you're going to get full visibility and control over what information is coming into your agents and what sort of information is going out to the world that's passing through the agents from your company's internal information, internal code base, and so on. The model proxy really becomes the centralized control plane for any sort of agent interaction. Now, this is really important because agents are consuming information constantly. They're going to be looking at Stack Overflow threads. They're going to be looking at documentation everywhere. And these are all opportunities for attackers to embed malicious information. This is a sort of macro approach to the prompt injection threat that Eric talked about earlier, because everything can be a potential opportunity for prompt injection. Agents are constantly looking for instruction, and if it's not getting it from you, the developer, then it's going to take it in from wherever else it's reading information from. Now, the benefits of model proxies, they're really twofold, right? There's the actual functionality of being able to block malicious content, of being able to sanitize prompts that are going out. But what I think might actually be even more important is the amount of observability that you can gain over how your developers are using AI. This can help you inform your AI strategy. It can help you understand the costs that are coming with usage of different AI tools and prioritize what to invest in and what to pull funding out of. Examples of offerings in this space are Light LLM, which is a building block, let's say. It's not really a comprehensive solution, and for most companies who adopt it, it's something that they have to do their own degree of customization and configuration to really make it work for them. Now, the other big example in this space is, of course, Coder AI Bridge, which is something that is more fully featured out of the box and is fully integrated into Coder workspaces. To reiterate, model proxies are taking an approach that has worked for many years when it came to other problems and really applying it to the sheer amount of attack vectors that AI agents can introduce to your code base, to your company, to your team. The last piece here is something I like to call agent firewalls, but to be honest, it was a bit difficult for me to come up with a perfect name here because this is such a new space that there's no real definition just yet. But you can think of these as process level safeguards. These are going to be rules for what an agent is able to access, both in terms of the network as well as the local file system. Without these restrictions, agents are able to reach anything and push to anything. They can access sensitive information on your own internal code base, on your own local machines potentially, and that they can exfiltrate that to the greater world. They can also be pulling all sorts of untrusted information from malicious domains. With unlimited access to the file system, on the other hand, agents are able to cover up their own tracks when things go wrong. Now, you can tell the agent, make a log of everything that you're doing, but if it has access to your local file system, you can go back and change the logs to whatever it wants it to be. Agent firewalls are really, really important because even in a CDE, if an agent has unrestricted execution permissions, it can still cause a huge deal of damage. Malicious packages can get installed, and that's actually been a pretty scary phenomenon happening recently because as most of us here who've messed around with AI knows, it has a tendency to create packages, create names of things that just don't exist. So there are malicious actors out there who realized, okay, we have a pattern of the sort of package names that AI can create. Let's put malicious code at those addresses, essentially, so that when the AI goes to those places to download these packages, they're actually hitting the malicious content. The thing is, because autonomous agents are operating at machine speed, anything it does over the network, over the local file system, can be done dozens and dozens of times in a blink of an eye. Humans are unable to keep watch over every single action an agent is taking, and as a result, it really comes down to secure infrastructure to enforce these restrictions. With agent firewalls, we can limit agents to installing packages from very specific domains. We can tell it, hey, you can't access information from GitHub, for example, because we know that GitHub is relatively public. Anyone can make a particular issue, and they can put content in that issue that might not be actually true. Now, I don't really have that many examples of solutions in this space because, as I mentioned, it's pretty new. I would say the most well-known would be Anthropic's Sandbox Runtime, which is an open source tool that allows individual developers to safeguard what their agents are doing. I will say it's not a great option for people working in the enterprise because it requires pretty high privileges in order to run. Now, if any of you work in a highly regulated industry, you know that you're not going to be able to give admin privileges to just any sort of tool. Now, Coder has two options for this. The first one is called HTTP jail, which is essentially what it says on the cover. And this is an open source tool that was written in Rust and got a call out from Simon Willison. And we also have Agent Boundaries, which is a more polished version built on the same concept that's written in Go and integrates natively with Coder workspaces. I do want to point out that I am dumping a lot of information on you, both in terms of repositories to check out and links to read up on, and I'm going to have all of that available to you in a QR code at the end of this talk. So if you're frantically taking notes, no need. I'm going to pass it off to Eric now to walk us through a demo of what's capable in Coder today along the lines of all three of these solutions.
Great. Yeah, thank you, Jiachen. And since I think we have about 5 minutes left, happy to open this up to questions as well as I go through the demo so we can make it interactive. So I'll go ahead and open up our demo environment here. Okay, so this is the Coder environment. We're hosting this actually in the US, but we have global support for regional proxies, so we have a local proxy here that I'll connect to when I interact with my workspace. So what I can do is go into tasks here, and I will bring this down over here. And we can see that we can prompt the AI agent with any given task that we want to execute. Now, this is going to consume a workspace template. So the development environments here are codified in Terraform via infrastructure as code, allowing for that sort of standardized and consistent experience that CDEs provide. So what I'll do is I will put in the prompt here. And then you can see down here are the templates that are available. So depending upon what the use case is or what the project is, I can kick off an agentic process in a given set of Terraform that would run either a container in a cluster in a given region that has access to the data that I need, right? So in terms of maybe GDPR and data privacy where we need to access data in country, you could have templates that federate development environments in various parts of the world for that. And then as well, this is just a template version. So version control would back these templates. So you could have a full CI/CD pipeline managing your infrastructure definition for these development environments. So we'll kick off the workspace here. I think we're running, I believe, Claude Code in here. So we're supplying that prompt on the back end via the Claude CLI to the development environment. And you can see that we're running the Terraform code here to build the dev environment. In this context here, it's a Kubernetes pod. So it's just a cluster, it's a pod that's running in a given namespace. And you can see that the startup script is executing. So we have something as well, an open source project called Agent API, which allows for you to expose a chat interface for any AI agent. So you don't necessarily need to rely upon say a Anthropic or OpenAI specific chat interface. What we're using here is Agent API, which is open source, and then we're, of course, surfacing the output that Claude is providing. Now, what I prompted it to do was just list current issues that are available in the project repository from GitHub. You know, go ahead and provide an analysis of each and just list them out for me, right? Now, I can interact with the application that I'm building here. Losing my mouse. There we go. So this is just the application that's running. It's a JavaScript game. I won't go through the entire game here, but you can see that that is running. I have VS Code in the browser. So at the beginning of the talk, I mentioned the open source project code server that we pretty much started the company with. That is here running in the browser, and then you have a native terminal as well. So I can say back to the AI agent here, maybe I want to work on a particular issue. So I will tell it to work on issue number 1 and make the card game maybe a bit more snazzy, if you will. Can't see if I have the bracket there. Yep. Okay. And I'll go ahead and kick that process off. Now, what I'll do is I will also just go back to the home page. And you can see that this workspace is running here, where I can also just have a nice dashboard to show all the tools that are available. So we have Claude Code available there, as well as other desktop IDEs that we can connect to over SSH. So it's a fully in-browser and client-side experience that we support. Cursor, one click over SSH, using the SSH remote official extension from Microsoft. Of course, VS Code is supported, but I feel like a lot of people are moving off of that. And JetBrains client. So JetBrains Toolbox is their remote solution that they allow to connect to remote servers. So we have a formal partnership with JetBrains for that experience. So this is really what you see when you're saying, okay, we're going to combine an agentic workflow with just a human engineering environment where I could go in here and click on the text editor of my choice and just start coding away on my own. And so this would link up to the tasks view here that we see, where I can actually view the process that was running as well from Claude. Now this UI is nice, it makes for a nice demo, but you're probably thinking like in an enterprise context, you probably want this all available as an API. So think a Jira ticket is filed, there's an issue with a piece of the infrastructure, or a ServiceNow ticket is filed, that kicks off a task API to run this container in the area of affected infrastructure to do diagnosis and log gathering for the, say, site reliability engineering team, right? So that's really the more advanced and enterprise use case, but this is really what the sort of end developer experience could look like. And then as well, maybe for that site reliability engineer, the logs have already been gathered, they can enter a nice UI here with single sign-on and conduct the investigation that they need to do. And then as well, we mentioned the network boundary solution that we have to block unauthorized access to other endpoints. So let's ask the agent to clone a project repository from an unauthorized source and write it to TMP. And so what this request is going to go through that AI bridge or LLM proxy that Jiachen referred to, and then it will also come up against the boundary. So you can see the GET request was from the Bitbucket host, and it resulted in a 401. So you can prevent, say, a junior or maybe senior or principal engineer from doing something malicious at a more enterprise-grade level, all segmented with particular templates, right? So this template is running in a particular area of your network or your infrastructure, so it might have particular network blockades, if you will, that would be unique to the project that's going on here. So yeah, that's really about it. I think we're almost at time, so could leave some space for any questions.
Yep, and I think if we could go back to the last slide, which
Sure.
has the big QR code that people can scan to see our link of resources, that would be great. So
Yep.
Key takeaways, people want to take a quick picture, and then we'll move on to the last slide.
All right. Well, thank you.